There's a little bit of Neanderthal in most of us. Neanderthals and Homo sapiens had a long history of intermingling until the former went extinct about 40,000 years ago. That mixing has led to some modern people having up to 3% of Neanderthal DNA. And while these genetic remnants don't have a lot of impact on our day to day life, it may have one surprising effect: pain tolerance. Joining me now to talk about new research in this field is my guest, Dr. Kosto Badakar. That is cool. Let's get right into your study. There are different kinds of pain, right? The pain I feel when I stub my toe, it's like different from chronic back pain, for example. What kind of pain were you looking at in this study?
Yeah, exactly. So we were looking at normal pain sensitivity or pain perception. And as you said, if we end up touching a hot pan while cooking, we want to feel that pain because that then keeps us safe, not burning our hand. And that is very different from chronic pain, which is not so good for us and is in fact something that healthcare systems spend billions trying to manage and treat. So we were looking at the first kind of pain, which is the normal pain perception, and that would vary a little bit between people to people. So that's what we were studying.
And for the people who have these Neanderthal genetic variants, just how much of a difference in pain tolerance was there?
It wasn't a lot. So, because we are talking about normal pain perception, so for example, if we touch a plate that's our body temperature, we won't feel pain. But if we start increase the temperature slightly, at a certain point, I will say that it's starting to feel hot, and then we will stop that experiment. So it's that kind of sensitivity we are talking about. That's one particular kind of pain perception or pain sensitivity we were measuring, and that would vary between people. Say you may feel that at 40 degrees Celsius, I may feel that at 42 degrees Celsius. So it's a relatively small variation, and correspondingly the Neanderthal contribution we saw were at this relatively moderate amount as well, but that is noticeable enough once you study a large enough group of people.
So the Neanderthals had a lower pain threshold. Do we have any idea why that would be?
That is a very interesting research question, which unfortunately we haven't figured out yet, and that's part of the next step in our research. So it certainly did something because we see that particular bit of gene that we inherited was under positive natural selection. So it certainly gave us some sort of advantage, but we don't know exactly what it was.
If Neanderthals had a lower pain threshold, would they have to be a little more cautious in how they live their lives?
Well, that's a good question. Might have been. So we don't exactly know what would the ramifications be in people's daily lives. As I said, it's a relatively small variation, and essentially every gene in our body does a lot of different things. So it's not necessarily that pain was the ultimate outcome characteristic that was influencing this natural selection. It could have been some other function of this gene. So it's a very interesting question. We don't know the answer yet, I'm afraid.
Do you think that because we humans survived with a little more pain tolerance, it increased natural selection toward us?
That is possible. There are hypotheses that even between different groups of modern humans, there are variations in pain tolerance, and that might have some advantages. So, a common example is malaria, for example, that there are selective advantages of people having malaria protective genes in certain parts of the world, and that might have been helpful.
Right.
So something similar could have happened. So we know that these Neanderthal people lived at colder climates, and they had various adaptations that helped them survive in these colder conditions. So we also know that they passed some of those genes that conferred this evolutionary advantage to modern people living in those areas. So might have been the same story with these pain genes, that something like that happened, but we exactly don't know yet.
Very interesting. A few months ago, you found that nose shape is dictated by Neanderthal genetic variations. Tell me about that. What you found there?
So that was study with the same group of people. What we do is, so that's how we found that there were certain changes in certain genes that modified our nose shape within, of course, the range of normal human variation. And when we did that, we found certain genetic changes in certain genes. But we also looked at whether we could have inherited those genetic changes from Neanderthals or from Denisovans, the two ancient groups of humans we intermingled with. And when we did that, we saw that there was one particular gene which was influencing our nose height, which we seem to have inherited from the Neanderthals. And again, there was probably some evolutionary advantage of having that particular genetic change. And we hypothesized that because the Neanderthals started living in these colder northern climates about 400,000, 300,000 years ago, they were much better adapted to that climate already when modern humans started to move in. So it's quite possible that when we intermixed with them, we said, oh, these genes are already giving you some advantage to living in these climates, we'll borrow them. And we did. And that's what we postulate in this paper.
What kinds of noses were inherited from Neanderthals? I was looking up Neanderthals, and it seems they had longer, broader noses. Was that an advantage? What kind of advantage did that give them?
So what we hypothesize, this is not something we can, do an experiment and prove, but what we hypothesized in our study and in several other studies by other research groups is that when you have a colder climate where the air temperature is much lower, you don't want that very cold air. Yeah, we definitely do. So we have recovered the DNA from Denisovans, and when we compare that to worldwide populations of modern humans, several groups have them. So East Asians, Southeast Asians, Native Americans, there are certain parts of Southeast Asia which have up to 8 or 10% of Denisovan ancestry. So that's quite interesting.
Wow, that is interesting. Is it possible that if you have Neanderthal or Denisovan genetic variants, if someone is curious about it, is there some testing panel? Can I get it tested to see if I have those genes?
I don't think you can get it tested directly from the consumer genetic tests. So this is a slightly more sophisticated genetic analysis that we do, but I think it's possible. So these testing companies might one day be able to implement these comparisons to say at least overall what percentage of your DNA could be Neanderthal or could be Denisovan. I think a couple of companies might do that already. But if you wanted to look at specific variants, whether those are inherited from Neanderthals or Denisovans, right now we know a fair amount about certain genetic variants. So these companies may one day decide to put those variants on the chip, and then at that point you would be able to find out.
Is it possible that there are more Neanderthal or Denisovan genetic variants out there than that we just don't know yet about?
Yeah, there's certainly that possibility. So you know that globally there are many populations that are understudied, and there have been recent efforts to increase representation in genetics research. So if that happens and we study more and more groups of people around the world, we'll probably find out more about it. Yeah, certainly.
And as far as the pain threshold, there's no way that I could know just by, maybe being more sensitive to pain that I have that Neanderthal variant gene, could I? I mean, it's what you're saying is it's really not that striking a difference.
No, you're completely right. It's not that striking a difference. So there are certain characteristics and certain genes which are linked in a very obvious way. For example, whether you are able to digest milk or not. Usually in European populations, that's down to a single change in a single gene, which gives you the ability to digest lactose. So those are examples in which it's very obvious. And if see that you are able to digest lactose or not, I will be able to see if you have the genetic variants or not. It doesn't work that way for most of the other characteristics that we study, like height, like face shape, like pain. So there would be a lot of genetic changes in a lot of genes that each give you a very small advantage or disadvantage, and therefore it is very difficult to say. I mean, the other thing, of course, is that there is a huge effect of environment as well. So for example, when it's a colder climate and you stub your little finger on your feet, it feels worse. So there would be, yeah, those kinds of variation. Or for example, for height, nutrition has a huge effect on height. So of course there would be in general a lot of difficulty in trying to link a specific characteristic to a specific gene.
Right. Well, next time I stub my toe, I can't say, darn those Neanderthal genes in me.
Indeed.
Fascinating. That's about all the time we have today. Thank you for taking time to be with us today.
Thank you for having me on the show.
Dr. Kosta Badakari, Assistant Professor of Statistics at the Open University in the UK.
Thanks, Ira. That's all the time we have today. As always, there's a lot of people who help to make the show possible, including
Santiago Flores,
D. Peter Schmidt,
Phyllis Samares.
Thanks, everyone. Tomorrow, we're going to wrap up the week's top science stories, and we'll try to see if we can use science to stop my cat from scratching the furniture. Find out more. Hope you can join us. I'm John Dankosky.